so far you have solved exact equations and some non-exact equations with an integrating factor that is only function of x or function of y alone. So, we will continue to reduce non-exact equation into an exact equation, but functions of x or functions of y alone, integrating factors may not work. Integrating factors that are functions of x or functions of alone may not work. When they do not work, you may have to look for some function of x y as an integrating factor. So, this is called the general method. So, inside if you want the general function, general integrating factor as a function of x and y, so what are the expression to check? Given a certain form of your integrating factor, you may have to check certain expression beforehand based on your m and m of x y and n of x y from the differential equation. Okay, we will see the general procedure in this video, and we will see when so not all equations you can get such integrating factors. So whenever it is possible, so you will give an expressions that are to be checked whether you will get integrating factor of function of x y in certain form or not. Okay, so let's take one more example where you may get we will see some more example. So example 2. So I will take simple example. So y minus solve y into 1 minus y dx plus x dy equal to 0. So how do I solve this? Clearly m is this, n is this, dou m by dou y which is equal to 1 minus 2y is not same as 1, which is actually dou n by dou x. It is not exact. So, but I try to make it an exact equation by, so my check is dou m by dou y minus dou n by dou x. What is this value? This is equal to 1 minus 2y minus 1. So, minus 2y. So, if I divide this with n, it should be function of x. If I divide this with minus m, then it should be function of y. So, this is my m, this is my n. If I divide with n, it is not function of x, right? Divide by n, for example. So, if I do it with x, it is not function of x. Okay? This is not function of x. So, this will not work. So, what I do is I divide with minus m. That is the condition you have if you want for a function of y. So, what is my m? Y into 1 minus y. So, this is equal to y goes. So, you have minus 2 divided by 1 minus y, which is function of y. Once you know this function of y only, what is my integrating factor? Integrating factor is mu equal to mu, which is function of y, as e power integral this function whatever you got minus 2 divided by 1 minus y dy, which is equal to, what is its integration? E power log 2 log 2 takes out 2 log 1 minus y, okay, plus some constant will be there. So, that e power this into e power that constant, okay. So, that will come here, that I can take it as 1. So, only at the end I want only some function of y with multiplying any constant is also an integrating factor, okay. So, you have infinitely many integrating factors simply by multiplying a constant 1, 2, 3, anything you can, any number you can multiply with this and you can say that that is a integrating factor. Is this log 1 minus y whose derivative is 1 by 1 minus y minus, so that is correct. So, this is equal to, we simply have 1 minus y whole square. Sorry, I think I made a mistake here. So, I have minus m is minus m is minus m is minus m is y into minus y. So, minus minus goes, this is plus. So, this is plus. So, I should have a minus here. So, that you have minus 2. So, this is your integrating factor. Okay. Once you know the integrating factor, you multiply this integrating factor to the equation. So, what is your equation? Y into 1 minus y. I multiply this with 1 by 1 minus y whole square dx plus x divided by 1 minus y whole square dy equal to 0. See, I have got this equation where x belongs to full R. I do not have issues, there is nothing like 1 by x, x is defined everywhere, y is also defined everywhere. Now you are multiplying this equation like this. You are multiplying this equation with 1 by 1 minus y whole square. That means at y equal to 1, this equation is not defined. You multiplying an integrating factor, after multiplying you have an issue at y equal to 1. So, it is defined, the reduced, what you got is the after multiplying the integrating factor, the differential equation is defined only at certain domain. It is not defined at y equal to 1, okay? Y should not be equal to 1. So, that means you can consider any domain that does not involve y equal to 1, okay? So, this mine, so you need not worry. So, whenever you see in the denominator and the denominator is becoming 0, at that point it is not defined. So, this is your equation. So, this will give me what happens. So, this one goes. So, you have y by 1 minus y dx plus x by 1 minus y whole square dy equal to 0. So, this is now exact. You can easily see dou m by dou y. Can you verify now? Dou n by dou x is this, dou n by dou y is so you can see that this is my m, this is my n. Now you can verify that dou m by dou y, that is 1 by 1 minus y plus y by 1 minus y whole square. So, that will give me 1 by 1 minus y whole square, which is equal to dou m by dou y equal to this, which is equal to dou n by dou x, which is simply 1 by 1 minus y whole square. So, it is an exact equation. Now, I know how to solve it. I fix my x equal to 0, x not equal to 0 and y not equal to 0. So, y is 0 is there in the domain. So, I can simply integrate m with respect to integrate from 0 to x y by 1 minus y dx plus integral y naught, I take it 0 to y. I replace x variable as x naught, which is 0. So, 0 by 1 minus y whole square I do with respect to integration is constant. So, the general solution is this. General solution of the equation is this. So, what is this exactly? So, this becomes y by 1 minus y is as a constant. So, x y by 1 minus y plus 0. So, this is equal to c. So, this is implies you can get your y. So, x y plus c y equal to c implies y equal to c divided by c plus x. This is your general solution of the given equation. So, you have two examples where we could check dou m by dou y minus dou n by dou x divided by either by n or by minus m, verify whether it is a function of x or function of y, and we can get accordingly what is my integrating factor. By multiplying that, you can make the equation exact and then solve the equation. So let's go back to the general case. General case, I don't want, see, I may not see, it may not work. Dou m by dou y minus dou n by dou x divided by n or divided by minus m may not be function of x alone or may not be function of y alone. It is function of x, y. Then what do you do? So what I do is I still multiply. So if you multiply mu of x, y, m dx plus I multiply this mx, y and dy equal to 0. This is a given equation which is not exact, m dx plus n dy. I multiply this. If I multiply, I hope this to be exact. So you have that equation. Mu has to satisfy, finally, mu has to satisfy n mu x minus m mu y equal to mu times my minus nx. This is exactly what we had earlier. Okay. So if you simply, this is just nothing but, this is my m, this is my n. So dou by dou y of mu m equal to dou x of mu n will give me this. Okay. Now I look for mu as function of x, y. Okay. It's not any general xy. If I say let mu is function of some v, which is where v is function of xy but specific form. This I can choose like v as v of x minus y, v of xy, v of x by y. These kind of specific forms I can choose as a function of x, as a function of xy, v. Okay. So let us choose, let us take like this. If I choose mu as mu of xy as mu of v, v is function of xy, but v of xy is actually a specific form like v of some, maybe something like x minus y. X minus a function of, this is a function of, so I don't write the same, so maybe some function means some, let us say g of xy, some g of xy. G of xy is as, or rather, so it should, no, it should be v of xy, where v of xy is some function, let us say g of x minus y. Okay. This or this or this. Okay. Something like this. This is how, if you look for it, then what you should, so what you just simply assume the form mu equal to mu of v, substitute into this. If you substitute, what we have, n, I rewrite mu x is, mu is a function of v, which is function of x, right? You can see this. Mu x is nothing but dou mu by dou x. This is equal to dou d mu by dv into dv by dx. V is a function of xy. Okay. So, right. So if I write like this, mu x is given by mu v into vx minus m mu y, that is dou mu by dou y is, mu is function of v, so d mu by dv into dou v by dou y. Okay. So this will give me mu v into vy in the place of mu y, which is equal to mu of v dou m by dou y, my minus nx. This is what it becomes. Okay. That implies, what is this d mu? D mu by dv. Mu v is common, that I write d mu by dv into nvx minus mvy equal to mu is a function of v, my minus nx. So this implies I can now, this you see, this mu is one variable, d mu and other things n vx minus m vy. So you simply write, so I rewrite this as mu d mu by mu, which is equal to my minus nx divided by n vx minus m vy. So you see, mu is a function of v. Okay. If I want to integrate this to get my mu, again like earlier, this should be function of v. Okay. So we can verify whether it's a function of v. See, what is your v? So a priori you choose, you can now check if mu is, if a v of xy is some function of let us say x minus y. Okay. If you want this, then it should be, or you simply choose g, not function of xy, simply v of xy is simply x minus y. This has xy, simple form x by y, any of these things. Okay. Then let us say x minus y. If you choose this thing, what happens to this equation? This equation becomes d mu by mu. What is mu? Mu is function of v. So that is mu of x minus y. Okay. Equal to, now you see this my minus nx divided by n vx. What is vx? 1. Now m minus m vy is minus 1, so that makes it plus. So this is what you have. So if you want a mu as a function of x minus y, which is v, then this quantity you have to verify. If it is, after verifying, you know n and m from the given equation, you can verify this. If it is function of x minus y, then you can integrate and get your integrating factor. That is the idea. Okay. So we will see if v of xy is xy. In this case, this equation becomes d mu by mu equal to, numerator is same, dy mu my minus nx divided by, now n into vx is y, vx is y into n, vy is x, so x into m. Now you will verify whether this is a function of your xy. Okay. If that is the case, then you can integrate and get your integrating factor. So if v of xy is x by y, so you can choose any form, maybe x plus y whole square. So anything, any in general. Okay. I will give you only one example here for any one of these cases, just to demonstrate how it works. Okay. So d mu by mu, here again my minus nx divided by the numerator, what happens, n, what is vx? 1 by y, n divided by y minus m, what is vy? Vy is vx divided by y square. This is what it is. So you have to see whether this right hand side function is function of x by y or not. If that is the case, I can integrate both sides and get my mu. Okay. So we will see one example. Solve xy cube plus 2x square y square minus y square dx plus x square y square plus 2x cube y minus 2x square dy equal to 0. How do we solve this one? This is not an exact equation. As usual, this is my m, this is my n. You can verify that dou m by dou y is not equal to dou n by dou x. Okay, you can verify. This is what is the case. So it's not exact, implies not exact. So how do we make it exact? Dou m by dou y, you calculate, actually it becomes dou m by dou y is 3xy square plus 4x square y minus 2y. Okay, this is what is this, which is not equal to dou n by dou x is 2xy square plus 6x square y minus 4x. Obviously they are not same, so it's not an exact equation. So but if you calculate dou m by dou y minus dou n by dou x, what is this? This, what is the numerator? So I'm just writing it. This becomes dou m by dou y is 3xy square minus 2xy square. So we have xy square, 4x square y minus this 6. There is going to be minus 2x square y minus 2y plus 4x minus 2y. So this is what is your this thing numerator. So if I divide this like in the earlier case, now I check either n of this n plus m, yn minus x, xm, or this quantity, either this or this or this in the denominator. I choose and see what happens. Okay, because I know this, so I'll check only this one, because if this will work. If you do n plus m, you divide it. If I do n plus m here, this may not work. N plus m is the case for x minus y. When I do this n plus m, I may not get this whole thing. When I write this n plus n is known, m is known, this whole function need not be, it will not become as a x minus y function. So that will not work. It should be function of x minus y. So I choose yn minus xm. So if I do this one, so what is yn? Yn is 2x y cube plus 6x square y square minus 4xy minus m is this, m is, sorry, no, I made a mistake. So y into n, so this is my n. Y into n is x square y cube plus 2x cube y square minus 2x square y minus mx, that is x square y cube minus 2x cube y square plus xy square. This is what is my yn minus mx. So what exactly is this? X square y cube goes, 2x cube y square, 2x cube y square goes. So what you are left with is minus 2x square y. So xy is common, x square y, x plus y. So this is what you have. So what I have is minus 2xy into x plus y. X plus y or x minus y? X minus y, right? 2xy, so no, this is actually not right. So you have xy is common, minus xy, you take it out, so you have minus, so 2x, and here xy square, so minus y. Okay, so you have minus xy, 2x minus y. What is this one? This is actually equal to xy, numerator xy, you take it out, you have y minus 2x, here 2 times y, or minus 2 times y minus 2x divided by minus xy, 2x minus y. So you can cancel minus 2x minus y, the denominator. What you get is xy minus 2 divided by xy. So this is exactly equal to 1 minus 2 divided by xy. So you can see, if I choose this, if I just verified this quantity is right hand side of this equation, this quantity is function of xy alone. I got this is a function of xy. You can see is a variable 1 minus 2 v is function of xy. So this implies the equation, once I verify this, I have this equation. From this I have to find my mu. So d mu by mu equal to 1 minus 2 by xy. Okay. So mu is function of xy, mu is function of v, where v is 1 minus 2 by v is xy. Okay. That's how we see, right? V of xy is xy. So this implies d mu by mu, which is equal to this I have a dv here. Okay. D mu by mu, when I rewrite I have a dv. So what I have is, so you have a dv you have here everywhere. Okay. So d mu by mu into I have 1 minus 2 by v into dv. So these are variables are separated, which are variables are mu and v. So this I can easily integrate to get log mu equal to, I can integrate, so v minus 2 log v, okay, plus log c. So what is the integrating factor? So mu is the integrating factor. If I calculate mu plus v square is my log. If I take this term and this term together, which is equal to v plus log c. So this gives me mu plus v square equal to e power v into e power c1. So if you call this c1, so there is a constant, I can take it as 1. Okay. So this will give me mu as e power v minus v square. So this is my integrating factor. So integrating factor is mu of xy is e power v is xy minus x square y square xy square v is. So this is the integrating factor. So if I multiply this integrating factor to the equation, which is this, we can make the equation exact. That's how we made the equation exact. So I simply write x cube. Now I take the equation xy cube plus 2x square y square minus y square into this integrating factor e power xy minus x square y square into dx plus x square y square plus 2x cube y minus 2x square into again integrating factor e power xy minus x square y square dy equal to 0. So this is now exact. What is the solution? Solution, simply integrate this. This is my m, this is my n, new m and n. Now exact with exact. Okay. So simply integrate. So solution is x naught to x m of x y dx plus n, this one, y naught to y n of x, you fix it as x naught to y dy equal to constant. So this I leave it as an exercise. So you take this m and n as these things. This is my n, this is my m. You put it here, that will give you the general solution. Okay. General solution of the given equation is this. This is the equation for this equation. Okay. This This is actually equivalent to the given equation because I can simply cancel both sides this integrating factor. So that gives you the original equation. Okay. So we can actually see the calculation now. I will not leave side, maybe I will do the calculation on here. So what is that? So I can fix my x naught y naught as 0 0 because this is part of the domain. There is no issue with 0 0. So you have integral 0 to x m is this one, x y cube plus 2x square y square minus y square into e power x y minus x square y square dx plus y naught is 0 into to y. Now in n you fix x equal to 0, x equal to x naught, which is 0, 0, this becomes 0, this becomes 0, this becomes 0. So 0 into whatever may be 0. So you have 0 dy equal to constant. So you simply have to integrate only this part if you can. Okay. So how do we integrate this? So this is what is the integration. So first term is 0 to x xy cube into e power x y dx. So y cube I can take it out because this is constant, x into e power x y dx. Second term 2y square is integral 0 to x, you can expand it, okay, x square e power x y dx. Now if you multiply this with this, now the last one is minus y square integral 0 to x e power x y dx. So this is what happens if you multiply this with each of these three terms and integrate. Minus y power 5 integral 0 to x x cube dx. Okay, and this if you multiply the second term here with the second term and third terms, you get minus 2y power 4 integral 0 to x y power 4, sorry, y power 4 we have, so you have x power 4 dx. It's not yet over, so you have plus y power 4 integral 0 to x x square dx equal to constant. So these are the integrations which you can do. Okay, so it's possible to do. So think of y as constant here. This you can integrate x into e power some constant into x, that you know how to integrate. Similarly, x square into e power some constant times x. This integration you can do and finally get this is your whatever the, after simplification you can get this as your general solution. I leave it here. Okay. So we have given a general procedure of finding integrating factor mu of x y. To do this, we have to check certain different expressions for different mu of x y. If mu of x y is in certain form, something like mu of x y, function mu is function of x y, which is like function of x into y or function of x plus y or certain mu of g of x y, g is known. Then we have seen what exactly the expressions in terms of m and n to check. So when you check, that expression should be function of this g of x y, known function g of x y. Then mu of g of x y, you know how to integrate, so you can find that integrating factor. Okay, so we have given the procedure how to find this general integrating factor with an example in this video. Okay, so far we have seen that. So maybe we'll do some more problems later.